attempt to control the variable. That's correct. But there's still always slight fluctuations.
Because he wasn't getting the expected results. That is the epitome of not a science experiment, bro.
That's where you're experiencing confounding variables, and you control for them and eliminate them from possibly interfering with your experiment. That is what an experiment does.
You didn't eliminate anything.
I mean, y'all can say that, but I disagree.
You think you eliminated electrostatics? How can someone even like say that out loud?
It grounded the apparatus. Everything that was metal on that apparatus was grounded.
Yeah. So?
Well, that's controlling.
It is an attempt to control the variable. That's correct. But there's still always slight fluctuations within electrostatics, and it can never be fully eliminated. And all the matter itself is intrinsically electrostatic. So what grounding does is it tries to control the surface charge. It never remove the intrinsic charge. That's what holds the matter together.
What do you mean everything? Yeah, but
like all matter.
The intramolecular charges are when an atom is assembled per se. It's not those intramolecular charges don't have anything to do with its interaction with other molecules.
Oh, really? Then what's electrostatic induction?
Oh, I don't know. I don't know.
Well, electrostatic induction is the transfer of charge to the surface of the object, and the matter itself is inducting the charge. Right. So
yeah,
it does have something.
But the bonding has to do with valence electrons and covalence and hydrogen bonds, and they're not to do with the intramolecular charges.
That's all electrostatic is the point, though. So like all the matter is, and you can try to get as close to neutral as possible, but you can never attain zero. It's well known that you can never attain zero. I used to work in an airport. We had to ground the planes before we fueled them, but we knew that it wasn't like 100% grounded. It was impossible. That's what we were trained on. Everyone knows this. If you look it up, Faraday cages, they have different prices.
It's bleeding off any static electricity that's built up on the plane surface, so you don't have a spark.
Right. Yeah, it's definitely trying to completely control the variable electrostatics, but it's impossible to completely do so. Now, it does it significantly. This is true. It gets a majority of it. That's for sure. But that's not the point, though, because even just the smallest amount conceivable is stronger than gravity claims to be. That's the point. If you got it 99.99% gone, that 0.01% is still going to be 10 to the 36 power stronger than gravity claims to be. All right, so that's the point that no one ever really addresses. They just...
So when you talk about that, the first thing I think of is if that were the case and electrostatics has anything to do with the downward acceleration, you could simply by grounding something change its weight.
No. Grounding something's not going to remove...
Come on, man. How can
grounding
you keep this routine up?
Grounding something's not going to...
Go ahead.
It's not going to remove the downward electric flow, which is what creates the downward bias. The reason things go up or down is buoyancy. Also, right, which is the buoyant force, which is way stronger than the downward electric flow. Just like if a beach ball goes up or if a helium balloon goes up, you claim that the buoyant force effectively overcomes gravity. Okay,
to argue that within their model, they have to say, no, it's space-time bending. It's space-time bending. And here's the thing I would say, what's causing space-time to bend? Their answer is circular. Their whole model, I mean, the gravity is just circular bullshit. We're
not talking about gravity. We're talking about buoyancy. Buoyancy is caused by gravity.
That's what, this is the point, though. When you say that, what it actually is little g. Okay? And little g is downward acceleration. The question is, what causes that? So the equation is the same if it's electrostatic. What?
You said the question was, it's the answer of why things go up. You said it overcomes gravity. No, it doesn't overcome gravity. Gravity acts on multiple objects differently. In fact, the force we know is proportional to the mass. So if we have a mass around it that's been displaced by an object, that force upward is equal to the weight of the mass that has been displaced. Very
You can't
simple.
just say we know it's proportionate to mass
know.
and that makes it
Through
true.
experimentation, we can show this. For example,
name something other than Cavendish that I've already thoroughly destroyed.
Can I give you an example?
Yeah.
So when I put a gallon jug of cement that weighs, say, 50 pounds on the surface of the pool before you throw it in the pool, and you lower it down onto a scale that's at the bottom of the pool, or use a spring scale to weigh, whatever you want to do. What will it weigh in the bottom of a water-filled pool? If it's 50 pounds outside the water?
I don't know.
Yes, you do. It's buoyancy. It's a simple buoyancy formula.
The cement?
Do you know what a gallon of water weighs?
No, what, in pounds?
In pounds, whatever, kilo, whatever you want. I can use all units of measure. About 8.8, 8.6, right? In that range.
Can you make the point?
Well, the point is, I just want you to answer the question. So if we know a gallon of water weighs 8.6 pounds, and this 50-pound jug of cement is lowered into a pool, what does it weigh at the bottom of the pool?
I don't know.
So you don't know basic physics.
Dude, you're asking me the number of what something weighs, okay? Just like, and then you pretend you were going to teach us, 8.8, it's 8.3. You don't even know what you're talking about.
It doesn't matter. That's not the point. The point is the exercise.
So,
if water can weigh, you can have heavy, water is heavier. Sure, of course you can.
Do you know how debates work?
What's the volume of that?
The question. So if you have this 8.3 pounds per 1 gallon of water, and you fill that gallon jug up with cement and it weighs 50 pounds, and you lower it in the pool and weigh it any way you want, spring scale or scale to the bottom of the pool, doesn't matter. What does it weigh at the bottom of the pool, Witsit?
50 minus 8.2, if it's just 1 gallon.
Excellent. Who was that spoke up?
Cyrus.
What is your point?
Although I asked it of Witsit, who seems to be a expert on almost everything here.
This doesn't change anything that I've said.
So buoyancy means that the water around it that has been displaced works as an upward force to any object that's displacing it.
Okay, that's my point.
But gravity, because the weight of that water determines the force upward.
Okay, so now we have to define weight.
It's not overcoming gravity, as you said.
Now we have to define weight.
Weight is just a force caused by mass in a gravitational field.
That's what you claim.
That's what it is.
No, so you claim that weight equals mass times gravity.
Correct.
And
mass has weight. It don't cause weight.
It's little g.
That is weight.
It's little g, which is downward acceleration. So it's a constant value. Okay, so that W equals mg is not exclusive to your claim of gravity. You understand that?
You said it changes. I agree with you.
You agree that weight is not exclusive to your claim of gravity, right? Weight would still be weight, even if space-time bending was wrong, correct?
Correct.
Right, so that's my point. The little g is not exclusive to what you think gravity is. So now we're back full circle to the question, what causes the downward acceleration? We have the same question. You understand that?
Does it matter? I can cause it by pseudo forces. I can cause it by magnetism. I can cause it by inducing other types of forces in there as well.
Now, this is the thing I've said to you many times. The difference is if we manipulate it with magnetism, coherent or incoherent, if we manipulate it with electrical charge, if we manipulate it with electrostatics, because we can manipulate weight with all that, right? Mm-hmm. That's all verifiable variables. We can actually physically manipulate those.
We
cannot do that with space-time.
You're getting ahead of yourself. We can that object still has weight. You can add other factors that can change the measurement of its weight, Doesn't change the weight of the object.
Not space time though, right? We can't mess with space time.
It doesn't matter what causes it.
Well, it does matter because what you're saying is the cause is unverifiable.
We're talking about the basic concept of buoyancy and weight, not talking about what causes it.
But that's the
We're
point.
talking
The
about
downward
proof
electric
of your
flow
gravity.
sets the downward bias, which gives you downward acceleration. We have an agreed upon average, or we use it as a constant, even though it's not constant. That's little g.
No one ever claimed it to be constant. They use it as a constant for calculations. It changes all over the Earth when it's near larger masses, etc. So it's very close to always being 9.81 meters per second square, but it's not.
Well,
always
yeah, that's why
exactly
it's
that.
the agreed upon average. It's pretty close to that.
Yeah, it's pretty close to that. It can change
Okay.
wherever there's more gravitational strength. That acceleration will be higher. Where there's less, it'll be less. When
Well,
you get
we're trying
further
to
away
figure
from
out
the
what
center of the
gravitational
mass-
strength is, Zanick.
Hold on. When it gets farther away from the center of the mass, it will go down as for the square.
Nobody's arguing that, bro. Zanick's
Yeah.
slow, but he's learning slowly but surely, Austin.
But
Stay
we're
at
trying
it.
to figure
I'm
out
slow.
what is
Okay.
the cause of the gravitational strength, Zanick.
Well, the common and most current science in physics says that it's the bending and warping of space-time.
That's right. Now, you know why that's a problem, though?
Why is
Because
that a problem?
that's just a story that can't be verified.
There's a lot of evidence that supports it,
There's not, though.
but there is.
No, there's a whole
Says
bunch
you.
of reification fallacies and presuppositions that are used to support it, but never is space-time directly manipulated.
They
So
don't
can you
have to
give me an
manipulate it.
example of space-time being directly
Why would you have to
manipulated?
do that? Why would you have to directly manipulate space-time?
Because that's
Although we
how
can
you
do
would actually verify it's the cause of the effect. That's why when
not
I
how
directly
communication works. Yeah.
manipulate, Zanick, when I directly
boy.
manipulate electrostatics,
Okay. Should we go
it
over this
makes
again?
things go up.
Zanick, what other kinds of time are there? If there's space time, what? Give me another time. If that's
let's not get
a
ahead of yourself
type
here.
of time.
First of all, you're conflating the experiment with the hypothesis, number one.
What?
Number two, in the experiment that you would tend to verify, validate, or support the space-time as the cause of gravity, you wouldn't need to actually manipulate space-time. All you
That's
have to
what you
do.
have to say.
No,
'cause you-
listen to me very carefully. All you have to do is manipulate an independent variable, whatever that may be, and see if it has any effect on the dependent variable, which is
Yeah, but you might be confusing it with some
Hey,
other kind of time.
no.
What
It
other?
doesn't matter. It doesn't matter,
Oh, that's
Brian.
not the
Yeah,
way.
it does because it's just a
No,
variable on
Brian,
paper, bro.
just because you say it doesn't, I'm telling you it doesn't. I'm here to tell you it doesn't. So the hypothesis can then change. Now, you don't ever have to manipulate space-time to prove that space-time does cause gravity. That's not how
Space time is a
experiments
made
work.
up word, bro. It's a made up kind of
So,
time.
Why
It's
do
a variable on
you
paper.
feel compelled to talk over me when I've been trying to be very good about not talking over you guys?
Sorry, I thought you was done. Sorry, man.
No, you didn't think I was done. Just couldn't control it.
I
And it
did think
happens.
you was done, bro.
No, you didn't. Come on. I mean, I can admit it when I do it. Just you can too. So
Bro, I
Thank
wasn't
you,
trying to come in over the top. I
Dean.
thought I
It
was
is-
just trying to come in
Hey,
right
just
after
be
you.
quiet for a second. So yes, the experiment to determine if space-time is the cause of gravity doesn't require you to manipulate space-time. That's not how
You-
it works.
You
The
have to say
experimentation
that.
phase would be what the observed phenomena is. It could be something falling, a rate of acceleration, etc. And then you try to alter that. So we try to vary the mass side, the distances between mass, distances between planets, whatever. Those kind of things we can actually vary. We're not going to be able
You
to
can
vary.
vary the
thing you
distance
think you
between
need
planets.
which is space-time, to prove that space-time is the cause of gravity. That's not
Okay,
how it
you
works.
cannot
There is
vary
no
the distance
space-time, bro.
between planets.
Now, you
Okay.
keep on barking that out, but that's not what we're talking about.
There is no
cannot
space
vary-
time. It's a variable on
No.
paper. It's not real, bro.
Okay, whatever you say, Brian, because you're
Okay.
What's
you're
causing
everybody else
space
is
time to bend, bro? What's causing what?
Mass.
Tell me another kind of time.
He's
So it's
gonna say
circular.
mass.
Right.
Mass
It's circular.
tells space how to bend.
Okay. Now, this is the point, right? Just because you say it doesn't mean that it's true. Okay?
Didn't say it's not about truth. It's about observation, repeatable, quantifiable, measurable types of experiments
Bro, you're not
that
repeating
we
anything,
can
bro.
do that support, give a large confidence of support to the theory that gravity is caused by the bending and warping of space-time.
Well, I don't have a large piece of confidence. You can't even prove that's a real thing. You know what I have confidence in?
Yay!
Electrostatics, which
Cool.
can be proven to be a real thing. We can
No,
directly
it really can't.
manipulate it, and we can change something's weight and how fast it falls. And in fact, we can even make something go up. So now I have a lot of confidence that electrostatics can cause downward acceleration.
Right. It's basically like science gave up, dude. They gave up and just y'all settled on some circular BS, dude, and gave up on what's causing what's truly causing it, bro. Y'all gave up and just made up a term.
I heard you the first time. We didn't give up. So Witsit.
Yeah, you did, because you're not trying to manipulate. You're not trying to figure out something real.
Right?
Well, look, let me finish. You're not trying to cause something. You're not trying to find something real that causes something. Yeah, go ahead.
So what Witsit said was that he added a different force, and because that force
y'all settled causes something. Yeah, go ahead.
So what Witsit said was that he added a different force, and because that force altered the weight or the force that we were measuring, therefore it is the force that is causing the other force.
No,
that's nonsensical. Because
Not what I
wind
said.
and upward draft, like we mentioned earlier today when we were talking about these kind of things.
That's
These
not what I
things are all
said.
real.
Why am I talking and you're talking over me?
Why are you straw manning me?
No, I'm not. I'm just saying that you can't just say I've altered something's weight by adding another force. Therefore, that force is the cause of that weight of the object. It's nonsensical.
Okay,
It's
so
truly circular logic.
If
It's
if I was
fallacious.
truly doing that, Zanick,
and
then
it's
you'd have a
fallacious for
point.
that very simple reason. So let me just finish with and I'll close with this one statement. So no, and just because electrostatics is 10 to the 32nd times stronger than gravity, it doesn't mean that it is stronger than gravity. And what I mean by that is because gravity can be as strong as the mass. It goes up with the mass. As the mass goes up, the gravity goes up.
Okay.
Electrostatics doesn't quite work that way.
Okay, you're right. It doesn't. So
You can have a
So
very, very
anyway.
large mass with a very, very large
Zanick.
weight.
Hey, let him respond, bro.
And it's not.
We heard you, bro.
Has
Let
nothing to do with
Austin
electrostatics.
respond, bro. For
Okay,
fuck's
so
sake.
if what you were saying was true, then you'd have a point. Because of course you can add a force to something, right? And then it'll overcome or counteract the forces that were already there. That doesn't mean that it's the primary cause of it, right? Like
You
if
said it
I
was.
pick up an object off the scale, that doesn't mean that the cause of the weight of the object is my hand. Duh. Okay? But that's
said
not
giving
analogous though, because the variable that we are manipulating is always present, which means I didn't introduce an additional variable that wasn't there. I simply manipulated the variable that is always there. Do you understand the difference?
No, I understand what you're saying, and you're wrong again. Just because we have things that have electrostatics as part of them, like a balloon that's sticking to those wall of a wall in your house, it doesn't mean that that's responsible for its downward acceleration. Should that electrostatics be removed?
You can't remove it. So if I take the balloon,
Yeah, you can neutralize it.
If I have the balloon before I rub it on my head, is it electrostatic?
Well, you're going to say there's electrostatics in all the molecules in all the atoms.
Yeah, there is.
But as far as measurable or any type of force that it can generate due to electrostatics, I'd say no. Most times, if you don't, before you rub it, there'd be something there. Obviously, all objects have some electrostatic qualities, characteristics, but it's not the reason that things fall down.
You're just saying that, though. Every time it boils down to the point where you're supposed to make your argument, you just baselessly assert it every single time.
Oh, come on.
You're baselessly asserting it, Zanick. That doesn't mean anything. You can't just say, we know it's gravity. We know it's not this.
You being right, and every physicist, and there's millions and millions of them in this world, you're right and everybody is wrong. Do you have an ego that large? You think you're that confident that you're right?
But
that's not.
So if electricity had anything to do with it, should we be able to make things like? Shouldn't we be able to manipulate the weight of things with electricity?
We literally can do that. Right. So what's now? What now? Like what? Now
It's
you should be like, oh
every
wow.
response Zanick
So
has is
Leflane, now you
about
should be like, oh wow. I guess that
yeah,
does make sense. But you're not going to say that.
exactly, and every
I mean,
response Zanick gives about
I've never seen
ventilation.
that. I've never seen making things, changing something's weight with electricity. I've never seen that.
You can change something's weight, how fast it falls, and its vector in entirety. You can make things go up. So the point is that we can prove that variable does cause the effect. Is it possible in theory that there's something else there that is the primary cause? Sure, sure. Is it required? No, it's not. So if there's something else there, we're going to have to actually verify that. We're going to have to actually demonstrate that to be true. We're not just going to claim it's there. You said that I think I'm right and all other physicists are wrong. No, not all other physicists think that space-time bends and warps. And of course, the majority of them do because it is assumed that relativity is correct because no one has been able to come up with something better to explain the heliocentric model yet. Okay, so
It's not designed to explain the heliocentric model, first of all.
why do you say things like that? General relativity is literally designed to explain the phenomena of gravity and the reason that objects go around other objects in space.
That's not that. See, you're confusing it yourself again with the effect. Regardless of what causes things to have weight, they have weight, and because they have weight, with regards to other or with respect to other objects, things have orbital characteristics. And those orbital mechanics are based on weight. It doesn't matter what causes the gravity, whether it's bending or warping of space-time. We can use simple math to actually calculate what the behavior of these objects when they're near each other. And that's what we see. So we don't need general relativity for it. Newtonian mechanics works just fine.
Okay, so you can manipulate something's weight and its vector with electrostatics. Okay?
Because it adds a force. So what?
That now you're claiming it's just adding a force, but
Of course it is.
electrostatics was already there. So what it's actually doing is manipulating the force that was already there.
That's what they do with everything they can't prove. They just make up. They make
You
up
mean
a
that's
fucking
not
word.
how it worked?
That's not how
Zanick,
it
is there
works
a
at all.
downward electric flow on the Earth? Yes or no?
You said you had a balloon, and before you rubbed it on your head, it had electrostatics, and I would tend to agree with you. And you
A
could probably
downward
measure
electric flow on the Earth?
Hold
Yes or
on.
no?
Hold on. And now you rub it on your head. Now we have a higher level electrostatic charge on the balloon that attracts itself to the opposite charge on the wall, so it sticks. You didn't change or add or do anything with respect to its weight. You just gave another force which attached itself to the wall due to electrostatics, static electricity.
Does
That's what he's talking about is real.
Does space have a resistance?
Does space have a resistance in what way?
Has electric resistance.
Does it have resistance?
Like an empty vacuum, there's still dielectric permittivity and magnetic permeability in free space. So that means it's always there. So how are you going to sit here and tell me it's not always there?
What's that? I had Siri or whoever chime me in saying what had resistance.
Okay.
What did you say about a vacuum? Is there resistance in a vacuum?
Yeah.
Well, there's some particles in the vacuum, but generally, no, there's no resistance in a vacuum.
Yes, there is.
How is it measured? What kind of? Give me a measurement of in ohms of what the resistance is of a vacuum.
7. It's like 377.
377 what?
Ohms.
Per what?
Meter.
Wait, so there's
why do I have to ask you for these critical elements of your claim? You should have told me.
Now you're just going to run away.
Per meter. So 377 ohms per meter?
Bro, he's teaching you, so just listen and
He's
learn.
not teaching me anything.
Yes, he is teaching you. Dude, he's claiming something real and showing real effects in real life, dude, not just making up a fucking term that's unfalsifiable, untestable. He's talking about real things,
what is causing the resistance in this vacuum?
Wow, good question.
Pardon me?
Good question,
Space-time.
Okay, so if I have an electrode and a cathode inside of a vacuum tube, and I apply
An electrode and a cathode.
Brian, shut up!
Bro, what's an electrode and a
I was
cathode?
talking.
You don't need any of that.
If I have a vacuum tube, I'm providing it for you. Make it easy. If you
You
say
don't
there
need
is
it.
377 ohms of resistance per meter, then I can roughly calculate with 100 volts, or let's say I have 377 volts applied to
Bro,
that
we don't need a lesson in Ohm's law,
Brian,
bro. We
shut
don't.
up. Brian,
You're fucking trying to give us a lesson in Ohm's law, bro. We don't need it.
Well, if I apply 377 ohms, volts to that 377 ohms, how much current will I get from that cathode and anode?
None of that
if I apply
matters.
voltage to one end?
The point is that there is vacuum permeability, that even in a vacuum chamber or quote unquote free space, there is impedance or resistance, right? So that means that it's always there. It's always there. And then, of course, when we have air, we have even more electrostatics, right? We have even more dielectric permittivity and magnetic permeability, right? And we have a downward electric flow. We have electrostatic induction. And we have equipotential increase of electricity. Dude, how is it that you deny objective reality?
Are you telling me there's less resistance with air than there is with a vacuum?
I literally just said the opposite of that.
Okay, good. So there's more resistance with air than vacuum.
I literally just said that.
I know you did. That's not how it came out. You can play it back, but that doesn't matter. I don't care. I'll take whatever your last answer is. So you say there's more resistance of air with respect to the distance.
Address
so
the actual point.
If you applied that 377 volts to that 1 meter distance between an anode and cathode in a vacuum, what would happen?
None of that matters.
Warp space-time, bro.
Of electricity. It's the
So you have a
Warp
magnetic
space-time.
constant
You're wrong.
known as the permeability.
Brian seems to know what Ohm's law is. Maybe Brian can answer it.
You have
Brian?
the magnetic constant, which is known as the permeability, and then you have the electric constant, which is permittivity. So just like I said, magnetic permeability and dielectric permittivity. And then you use the convention of the speed of light, right? And this is how you get the impedance in a vacuum. The fact is that it's there, right? That's the point. That means it's always there. You can never remove the magnetic constant and the electric constant. Never. You can never, ever, ever remove it. Ever.
Never, ever, ever.
So that's the point, man. Never ever seems so long. So yeah.
Also, there could be areas in space that have more charge than other areas that we don't even know of.
Doesn't even matter though. There's the fact that there's a magnetic constant, an electric constant, or permeability and permittivity in free space. I mean, it's everywhere, including in a vacuum chamber. And then when you get to the air, you have even more. So that's the point, right? We have even more in the air, and that's everywhere. So of course things go down. Of course things go down.
Well,
it has nothing to do with space time.
I'm laughing because I kind of set you up for that one, but dude,
you didn't set me up.
Seriously, the vacuum. You said air has more resistance in the vacuum.
It has greater permeability or permittivity.
Well, no, you're saying the opposite. I said, does it have more resistance? You said yes. There's more. That's what I said. You made a big point of that, and you know the answer is not that. The answer is not that air has more resistance. The vacuum has huge amounts of resistance. I mean, it's infinite resistance.
Resistance, though, doesn't it, Zanick? So it does have resistance. Let's not
wait, Zanick. What?
Of course it does.
The vacuum has more resistance than air?
Yeah. So you guys don't know anything.
You just looked it up, Zanick. And then you tried to spin it and say that you set me up.
I told you the vacuum had more resistance than air. I told you that right.
You just looked that up because where did that come from?
How do you think?
He looked it up and then said, I set you up.
How do you think? Well, I've been talking about vacuum tubes for a long time. You've done your TV set, your amplifiers. How do you think vacuum tubes work? How does the current travel in the vacuum tube, Brian?
You see how he's going to do anything in the world other than concede the actual point, which is that you can never remove it. You can never remove magnetic permeability and dielectric permittivity. It's always there, which means it's always a variable, no matter what. Admit it.
Magnetic permeability? Yes.
Yeah,
magnetic fields.
Well, how do you think we get the impedance of free space?
They don't need any kind of medium. But air does not have more resistance than vacuum. Vacuum has infinite resistance.
Oh my God. Okay. So this is the point.
So I don't know where you got your 300 ohms per meter from. That's a lie.
377 ohms.
No.
What do you, dude? That is known as the impedance of free space.
Infinite resistance in free space.
Oh my God. You clearly are trying to read it right now and figure it out and then debate it. Okay? Maybe you should read it before you try to debate it. None of this matters though, because you tried to claim that it isn't always there. You're just wrong.
What isn't always there?
The electric nature of all things, including the medium, and then
here
free
you go.
space is a medium
because
it has resistance.
Resistance, impedance. The impedance of a free space vacuum is exactly 377 ohms. That's what you're talking about, right?
I thought you just said it wasn't. I thought you said it was infinite, and I was wrong about that.
The impedance.
Yeah, the impedance. That's what I said.
That's ohms, you dumbass.
So let's define what impedance is.
That's the unit, dumbass, for fucking impedance. It's ohms, you fucking nut.
Oh,
so why did you just say that I was wrong and it was infinite?
You are wrong.
He said you lied. He said you're a
Ohm's
liar.
law doesn't apply to a vacuum.
Oh my God. Then what is free space then?
You tell me. You came up with the number.
I didn't come up with the number. I didn't come up with this. Zanick, you don't know anything about this. It's okay.
I do.
That doesn't mean you have to pretend like I'm wrong.
In a vacuum, there's nothing to conduct the electricity. So it has infinite resistance.
Oh my God. Okay. This is why I brought this up, because you say
looked this up on
stuff
YouTube or something, and you found some kind of like crazy.
Okay. So the impedance of free speech.
I think I found what you guys thought it was. I found the exact number.
The impedance of free space is a physical constant relating the magnitudes of the electric and magnetic fields of electromagnetic radiation traveling through free space. That is the electrical field strength and the magnetic field strength. A presently accepted value is 376.730313668 ohms.
There's nothing in the vacuum to conduct
There's no such thing as nothing.
There's nothing. There's not enough of whatever is there to conduct any electricity.
Hey, is there dielectric permittivity in a vacuum?
The resistance is infinite. You need air.
Is there electric permittivity in a vacuum?
Pardon me?
Is there electric permittivity in a vacuum?
Electric permittivity.
Permittivity.
Permeability? Yeah. Would you say permeability?
No, that's magnetic permeability. Is there electric permittivity in a vacuum?
Permittivity.
Yeah.
You can't conduct electricity in a vacuum. You need a medium.
Hey, is there
you have argon gas or some kind of a neon gas or something so that the electricity can flow through it.
Is there electric permittivity in a vacuum? Even at low voltages, electricity can in fact travel through a perfect vacuum.
How?
Well, this is just what your religion even acknowledges.
No, so. I don't know how it can. All the experience I've had, you can't have a conductor, one conductor to another conductor in a vacuum that can conduct electricity, have electricity flow across it.
Yep. A vacuum arc can occur if the electric field is sufficient to cause field electron emission.
There we go. That's different.
How is it different?
Because you're actually creating a field with other particles. Okay. Electrons are being shot across the vacuum.
Okay, so here's what you don't get. Yeah, you're still this is what you don't get. A vacuum chamber is not literal emptiness. Okay, this has been known for over a decade across the board. So stop saying it. The point is that there is dielectric permittivity. There's electric permittivity.
Or,
is there an electric constant and magnetic constant in a vacuum? Yes or no?
Pardon me?
Is there an electric and magnetic constant in a vacuum? Yes or no?
There's a magnetic constant in a vacuum.
Is there an electric constant?
I don't know.
Yes, and that electric constant is called electric permittivity.
But you already gave us the ohms of a vacuum, which was incorrect.
It's 377.
It's not.
It is.
No.
So I have to cite it?
You're going to cite what I just found for you, which is in Quora.
Too funny, man.
You're funny.
You just deny things. And like everyone knows the vacuum isn't empty, man. Stop saying that.
What did you find on Quora? Can you read it to us?
Me?
Yeah, you just said you found it
Yeah,
on Quora. Read it to us.
Yeah, I found where folks who work with electromagnetic effects in a vacuum never refer to resistance but impedance. So the impedance of free space vacuum is exactly 377 ohms. It has a pi ohms. But twin lead wiring that connects your TV antenna to your TV tuner has this resistance to maximize the power transfer. Often there is just a short length of this 377 ohm cable that is then the impedance matched to a 50 ohm coax cable. Impedance matching is done by a transformer. That's where you got it from.
Of course, this all reifies the convention of the speed of light, but the convention is useful, right? So it doesn't matter. The point is that there is like an electric permittivity even in a vacuum chamber. So you always have the variables of the electric and the magnetic in all things, including a vacuum chamber, right? Which nature abhors a vacuum anyway. So everything that's falling is within an electric medium. Everything. And everything is intrinsically electric. Therefore, you cannot claim that the phenomena of something going up and or down has nothing to do with that. That's ridiculous.
It doesn't. And it's demonstrably shown that it doesn't have anything to do with why things fall.
And why can I make things float by manipulating it?
You can manipulate that variable in all sorts of ways that show that it's not one of the forces that is causing it to fall.
Well, I can make things float by manipulating it, though.
That's adding another force to it. Like, oh my God. Or this like
you're saying, you keep saying adding another force.
No, you're adding it. You're adding or subtracting to it.
No, you're not adding it. It was already there.
No, it's not already there. Because if it's
so
there,
we
you
just
can measure,
covered it, right? We just covered it is already there.
Show me
now
the
you're just back to denying it's there.
You know what you do? Measure that static electricity and then measure it on something that actually is neutrally buoyant and see if you can get the same value. You won't.
So the reason we had to go through all this was because you keep saying it's not already there. Because your main argument is, oh, you just added a new force and that's why.
You did.
No, you manipulated
like you said,
the magnitude of the
objects
force.
Are generally electrostatic, and I would agree.
You manipulated the magnitude of the force that was already there.
No, you used a force on it. Just because it had some electrostatics doesn't mean you induced electrostatics into it by putting it into a magnetic field.
Actually, what we do is we manipulate the electrostatics in the medium around it, and then via electrostatic induction, you can make things float.
Induction. Okay. Well, you can do this. We can do this ionized gases. We can actually get large electromagnets, huge electromagnets, and we can actually move and create pressure zones in a chamber by using only magnetism.
You can manipulate the electric charge distribution inside of an object via electrostatic induction.
Only
inside of an object.
Oh, inside the object itself?
Yeah, that's what induction means. Where do you think it's being induced into?
It's on the surface.
Oh, it's inducted just on the surface? It doesn't go into the matter at all?
It's on the surface.
So you can't induct electrostatics into the matter?
So you can induce current into matter, for sure. The copper wire is how you can induce current through a wire.
Oh,
That's how windings work in motors.
So you can manipulate the electric charge inside the matter with electrostatic induction.
That's not considered a charge. Electricity isn't a charge.
Electric charge inside of an object can be manipulated with electrostatic induction.
Which is charge of your helium balloon?
What every time it gets down, we're talking about the principles, and you want to always come up like, oh, pop quiz, let me ask random questions about numbers.
No, you didn't even
I
know
don't care about the numbers.
You didn't even know what buoyancy was.
Oh my God, you're freaking out. This is your tactic. The reason I don't answer your questions is not because I can't answer them. It's because it's a tactic. It's a dishonest tactic.
Everything's electrostatics. I get it. That's your philosophy. That's your cat call.
It's a fact. Right?
It's not a fact.
It is a fact. Name one compilation of matter that's not electrostatic.
No, you're using it in context. That's what's causing the motion of all objects.
All right.
Yeah, you can't have any object that's not intrinsically electrostatic. Via
A
electrostatic
rock.
induction, you can manipulate the surface charge and the intrinsic charge of an object. And then, even in a vacuum chamber, you have a dielectric or electric permittivity and magnetic permeability. You always have you have electric resistance or impedance, more accurately with impedance, even in the vacuum. We have electrostatic field in the air. And then when you manipulate the electrostatic nature of the medium via electrostatic induction, you can make things flow and you can change how fast that they fall. This is all objective. Everything I just said is not up for debate.
Yes, it is up for debate because you're not using it in the proper context. What's
Oh
it?
my God. You got nothing with any substantive specificity, but
I
Austin's so
gave you
stupid. He
substantive
dropped out of college. He's so
specificity
stupid.
several
Then how come all
times.
these people with credentials that are debating me can't actually debate with any type of value?
Oh, because you're so smart. You're so smarter than
It has
all the
nothing to do with
physicists
me
who
being
talk.
so smart. It has
Because
something to do with
you
your
need an
ineptitude.
ego check, man. You are so out there.
It's not about me. I'm just
You
some
don't
dude. There are
understand.
people way smarter
You
than me,
understand
Zanick.
95% of the things you talk about here. You don't understand at all.
Zanick, there are people way smarter than me. It has nothing to do with me. It
Really?
has to do with you.
Me? Really? Has nothing with me. I
Yeah, you're
know.
logically fallacious.
I know. I'm not logically fallacious.
You literally
You
are.
know. You already said you think things happen for a certain reason. You said that things fall because of electrostatics. There's no physicist on Earth that says that. None. Not one.
Does electrostatic induction go into the material, yes or no?
Electrostatic induction? I haven't heard that term before.
Okay. So who is it
Is
that's
that not a
arguing
Kim
about stuff
Wheeler's
they don't
book?
know again?
Let me look that one up because I haven't heard electrostatic. Electrostatic.
Okay. So
But
you
if
can
Kim
never remove this variable.
Wheeler's
The only
face
reason this
pops
has
up,
gotten
that.
so in the weeds is because when I bring up
I
that
already
you can
talked.
change the
I was
weight, you
telling
can
you
change how.
about what induction meant.
Oh.
I
The
was.
only reason that this all came up was because when I brought up that you can change the weight, you can change downward acceleration rate, and you can even change the vector as a whole by manipulating electrostatics. What you said was just because you added a force. I said, no, that force was already present. You're manipulating the magnitude of that force. That's why that rebuttal's not sufficient
How are you?
because it's
How are
not
you
the same as if I introduce a new force like I picked an object up because my hand wasn't on the object till I introduced it, right? That's not the same as that object's already electrostatic intrinsically and on the surface, and the medium it's in is electrostatic. Then we're just manipulating the variable that's already there. And when we manipulate it, we can make something go up. How do you understand this?
No, it's caused. These charges are caused by charges around them. That's what doesn't mean they're already existing. You're actually influencing the static electricity inside an object or on an object or about an object or in the surface of an object by putting it in the presence of another set of charges.
I just said that.
But I said that from the beginning. It doesn't matter. You're not creating something that's not that you're creating something that's not even it wasn't there before. And so that doesn't
You
tell
see what he's
that
doing?
an additional that additional force is something you're adding, as I've always been saying to you.
Okay, so
It
do you
wasn't
see what
there
he's doing?
originally. It wasn't manipulated. You actually added to it.
No, yeah. You manipulated the amount. You can say you added to it or whatever, but the point is that you didn't
No,
add
that's
something.
not whatever. You don't hand
Zanick,
wave
stop
that.
interrupting me or I'm going to mute you. That's the 5th time in a row.
He's trolling you, man.
Well, no, he's actually just desperately trying to redisguise the conversation as if he's been right the whole time. Okay, first of all, just
said
less than
nothing
2
wrong.
minutes ago, you were telling me it doesn't go in the object. Now you're saying you've been saying that the whole time when you literally just denied it 5 times. Secondly, Zanick, what I've been saying the whole time was that if you manipulate the electrostatics of the medium via electrostatic induction, it will transfer to and inside the object, and that you can change the vector of the object. I've been saying that for 10 minutes straight.
I said this from the very, very beginning. You add a force to it, it can change its rate of descent, its falling acceleration. I said that. You know I said that.
But you keep
And you're
saying if you
adding
add the
something,
force, so
which
before
doesn't mean
we,
that just because you. So I'm talking now. You're interrupting me.
well, you pause
So
because you have no idea what you're talking about. You're
I didn't
like a
pause.
fish out of water right now.
I didn't pause. So I said this in the beginning. Just because you add a force to it doesn't mean, and it changes the motion. It doesn't mean that's the original cause of the motion. I'll say that again if you want me to.
Okay, so I can say the same thing about when you manipulate mass then, huh?
Why would that be equivalent?
Oh, bro, pick your body up off the ground. Oh, it must sting.
If you add mass and nothing else, if you add mass and nothing else, and that acceleration remains the same, that means the force went up. And all you do is add mass. You didn't add a force. You added mass. The force was created by the theory and the idea, and that's the cause and effect relationship, that mass causes force.
Well, you could just be adding a new force. It doesn't mean it's the cause of it.
Could be, but I'm not.
Oh, how do you know?
Because you've already described how these forces actually change the vector.
Yeah, but you're claiming that the mass of the object.
You already agreed that it's a force.
You realize what just happened, don't you? I can tell you realize it.
You're
smart enough to realize
Yeah, of course
it.
he realizes it. He's trying to act like he's been right. He's trying to act like he's been right the whole damn time, trying to sideways join your point.
Brian,
I know he's done it with like 7 different parts of it.
Yeah, right.
No, everyone's sitting here now. The left lane and Kosho will jump in, or maybe just left lane, and act like you actually were right the whole time. Everyone else that hears it knows that's not true, though. Literally everyone else. Wrong. Okay, so here's the deal, man. Here's the deal. You claimed I can't claim it's the cause of the effect because all I did was add a force to it.
Correct.
I'm like, oh, okay. The difference is I can actually physically verify this force, right? So I know it's there. So at the least we need to set this. That makes the
problem worse.
Dude, it's like hearing me coherently make my point terrifies you. So we know that the manipulation of this force, we know that the manipulation of this force can change the weight, change the downward acceleration rate, and change the vector. Now we're going to set this piece of evidence over here on the table, okay? We'll set it on the shelf. We know that's the case. We verified it, physically verified it. Okay, now we're going to come over here. Zanick claims that we're just adding to what's already there, and that's not the actual cause. It's something else. Okay, what does Zanick claim it is? He claims that mass causes the bending and warping of space and time to result in not technically a force, but it acts as a force. And it's the bending and warping of space-time. Okay, so can we physically manipulate the variable of space-time and prove that happens? No, we cannot. Okay, so it doesn't get to go sit on the shelf with the other piece of evidence because it's stupid. What?
No, you can't go to the cause of the cause because we're not talking about the cause of the cause yet. That's like me saying what's the cause of a static electricity. We're not going there. All we need to know is that there is a force caused by the mass. You don't need to know the cause of that cause, as I've always said. You are adding static electricity. You're adding static electricity to this environment.
It was already there, though.
I'm not adding a force. I'm just adding more mass. And that
I'm
mass
just adding more electrostatics.
Oh, God.
Zanick is such a reluctant learner, bro. Zanick, if you weren't such a reluctant learner, bro, you'd learn way faster.
I'm guilty of being educated by
bro?
Coach gonna come try to save him.
I hope so. I hope someone's going to come, add.
You need some help. Osho can even tell you need some help.
Dude, you're not the smartest guy in the room. You're not smarter than all the physicists of the world. You have a harebrained idea, which you seem to think has validity.
Resorted to ad homs.
Hold on. No, you just don't understand physics because you've tried to learn it on YouTube.
More ad homs.
Okay. No, I'm just saying what people are doing.
Order in the court. Gaslighting.
You've learned on YouTube.
Osho, go ahead.
Zanick, we literally just had to teach you that ohms, the unit for ohms. I mean, the unit for ohms is impedance. Okay.
No,
he literally had to teach you that. Let me finish, bro. You ain't got to interrupt me. He literally had to teach you that that electrostatics is pretty much ever present in all matter.
The unit of measure of ohms is not electrostatic. Whatever you said there.
No, he said the unit is ohms.
How wrong?
The unit of measure of resistance is the ohm. Dude, listen.
It's expressed in impedance, bro. It's expressed.
The unit of impedance, like that of resistance, is the ohm.
Ohms is resistance, yes.
And impedance.
It's impedance.
Not impedance.
Really? So Britannica's wrong, left lane? Can you cite me your source, please?
Isn't it microfarad or something?
No, that's capacitance. That's capacitance.
That's capacitance, yeah.
So you're wrong.
Ohm is a unit of measure of resistance. Now, resistance and impedance are closely related.
The same thing. They're the same thing, bro. You don't say resistance, bro. You don't write down resistance, bro. You write down impedance.
Close enough for our conversation, but they're not the same.
Britannica, what is the units for impedance? The units of impedance, like that of resistance, is the ohm.
What is the difference between impedance and resistance? Why don't you tell me that real quick?
It doesn't even matter. You admit that you're wrong about this.
No, it is an ohm, but impedance is not the same as resistance. It's closely related.
It was. That's a straw man.
No, it's not.
I didn't say it was, so that's a straw man.
No, but your buddy Brian did.
No, he didn't.
You're putting words in my mouth, but the whole thing is this. is you're learning slowly but surely. But dude, you're just, I mean, you're offering so much resistance, bro. You'd learn a lot faster if you just listen and then disagree at the
You're gonna
end.
re-educate
You're
me.
just adding up fallacy after fallacy,
Career,
bro.
a successful career, building things, making things in
Now he's
electronics
chanting.
and electromechanics, and you're going to teach me, who had no experience in this field. How is that logical to me?
Zanick, do you realize how what we see here is that you're having to like patch up your ego right now? And
I have
like,
no ego here. You guys don't know me. I don't need to do anything.
Left
I
Lane,
can
would
just
you
hang
like
up.
to admit
I
you
can
were
hang up the
wrong
phone
when
if
you
I
said
want to,
ohm
right?
wasn't the unit for impedance?
I didn't say that.
I said Left Lane.
No, I did. Yeah, I wasn't sure, but I did know that ohms is the value
Resistance.
for resistance, but
Yeah.
I wasn't sure about impedance.
It's all good. Okay, so you were wrong. So the point is that if we're all wrong, like I've learned stuff from Zanick, I'm wrong about stuff all the time. But you don't have to pretend you're never wrong though, right? Like
I
Zanick,
never
we
said
all
I'm never
heard how
wrong.
you tried to tell me that electrostatic induction doesn't go to inside the matter. Then you turned around and said it did. And
Well,
then you turned
I
around and
said
said
it
you
didn't
didn't know
matter.
what
I
it
said it didn't
was.
matter whether it goes inside, around the surface. I said
You
it very
said it
clearly.
didn't
I
go
said it very clearly.
inside
Go back and listen
it.
to it.
You said it did not go inside
For the static
it.
electricity, it didn't go inside it. It stays on
Yeah,
the
but you're
surface.
wrong. You're wrong.
Okay, great. I'm wrong. Big deal.
Okay, thank you.
Doesn't matter.
Now, another thing that
Doesn't
you're
matter.
wrong about is you're claiming that you can remove it or it's not always there. It is always there. That's what got us into the 377
So when you
ohms.
add,
Once again, you were
when you
wrong.
add static electrostatics to a balloon, it has more force acting upon a attractive, an opposite field.
But electrostatics was
opposite
already
field usually
there,
on
so
the
you're
wall or your
manipulating
head.
the amount of electrostatics that's there.
You're giving the electrostatics by rubbing it on your head. You're giving it from your head to the balloon.
Okay,
You're
so
giving it
before I
positive,
did that, was there any electrostatics there?
but that's not what you've excited. You've added to it.
Oh yeah, you've added to it. You've increased the
Oh,
variable of
this is why I
electrostatics.
can't take it. What's it?
Yeah, you
You're
can't take
talking
it
in
because
You're
we're
saying
just
you
circles.
getting
can't take it, bro.
sliced
No,
up right
dude,
now.
you're talking in circles, and I don't need to
You
do what
are
you're saying
literally
here.
just saying two different things in two sentences, bro. You just said that it
No,
wasn't there. Hold on, you just said it
This-
wasn't there, and
that's
then
like
you said
saying
you added to it.
okay, in a vacuum, da da da. Oh, but there's no such thing as a perfect vacuum.
Da da da.
Well, no, that's true. Oh, see, I got you. That's not a got you.
No, no
In
one
fact,
said
There's
gotcha.
so little electrostatics on a standard balloon that has not been exposed to other types of fields. That yes, is there something there? Absolutely, but there's not much. But when you rub it on your head or you put it in a field where they can actually have
And there's
electrostatic,
way more, yeah.
then there'll be more. You've added to
Duh.
it. Now it has. It's like making a magnet.
So
You're
quit
making
saying that it
lithium.
was. So quit
Oh,
saying it wasn't
Brian,
present,
I don't
bro.
need you yapping in the background, screaming.
Quit interrupting me every time I'm going to talk. Quit saying
Quit
that it wasn't
screaming.
present,
You were
bro.
cutting him off.
Coach, I'm
You
just
keep
gonna say though,
saying
if you come in
All right.
here and you pretend that Zanick's been right this whole time, I'm gonna lose a lot of respect for you. I'm just giving you a heads up because this has been
Well, I've
really.
already lost. I've lost. This is what I don't like is when people speak for me before I get the chance to speak. I wasn't gonna agree with Zanick.
I didn't
I was
speak
gonna
for you.
show. Yeah, but twice. That's twice in a row. It's really aggravating because it's obviously I know what I'm going to say, but what I was going to say is in the case of manipulating something with electrostatic charge, like a balloon, for instance. Uh, Zanick is saying you're adding force, but I think in both cases, let's say you wanted to do different tests. In one test, you would manipulate the amount of mass, and then in the other case, you would manipulate the amount of charge, and you can do that by rubbing a balloon, and changing the balance of the electrostatics. But I think in both those cases, I think that you'd be able to uh, manipulate without actually adding force, just by manipulating attributes of it. So,
Yeah.
but that wasn't my main point. My point I was going to make was everyone knows that electromagnetism is like 30 something times orders of magnitude stronger than gravity intrinsically. However, when you look out in the universe, it doesn't seem like electromagnetism is doing, like, making galaxies and all this other type of stuff. And the reason why that's the case is not because gravity is all of a sudden stronger. It's because the electrostatic potential or any electrostatic charge, the only time it's going to have it's the only time it's going to have an effect worth, doing anything is when the net charge is imbalanced. So if an object has intrinsic charge, but it has a net charge of 0, like a volume of helium or something like that, then it's not going. It doesn't matter. You're going to have to add charge to it if you want to see it have any kind of effect. So, using it as saying that it has intrinsic charge, and so that's how it is compelled downward. It doesn't. There's nothing that is influencing it to do that, even though it has intrinsic charge.
Right.
How do you know that?
The thing is, man, is that it's not like we're claiming that it's like this attractive force pulling down the balloon, right? Because like you said, in order for that to happen, there would have to be an imbalance, right? There's no doubt about it. Okay, but that's not what's being claimed. What's being claimed is that there's just a downward electric pressure or bias or flow. It's very, very, very weak, okay, but it's still there. And then the intrinsic electrostatics of the balloon and even on the surface, in that scenario, if you take the balloon, you drop it, it's going to fall, right? It's really close to being neutral. It's very, very low, okay? But it doesn't matter. The fact is just that it's there. And since we know no matter how low it is, it's stronger than gravity, okay? It has got to be accounted for as one of the primary variables, right? That's the point. It's like when I take the balloon, rub it on my head, stick it to the wall. It sticks to the wall because I've added more charge to it. It's going to slowly lose its charge, then it's going to fall down to the ground. As it falls down to the ground, it's still electrostatic. The air is still electrostatic that's falling through, and the ground that it hits is also electrostatic. So it's all electrostatic. That's what's going to set it up and down. It's not this like attractive force pulling everything down to the earth, though, right? And that's the major disconnect. And that's why everyone thinks they know for sure that I'm wrong, and they constantly refute me, and my electrostatics is wrong.
Well, you are wrong.
Because if they were right and that was my stance, then I would be wrong. But that isn't my stance, though. Okay, I don't think there is some attractive force pulling everything down from miles and miles up. That isn't my stance.
It's all reacting with each other. All the medium and the objects are all reacting with each other, is what you're saying, man.
Of course they are. That's why when you manipulate the medium, it changes the object's vector. This is for density and for electrostatics. That's what a Van de Graaff generator does. It messes with the medium that the object's in, and that's why the object goes up. Okay, you don't just introduce charge directly to the object, then it floats. You're manipulating the electrostatic charge of the medium.
Yes,
and then the object will float after electrostatic induction occurs.
So no, the field when it's in a field, it will induce the electrostatics into that object, like the balloon or like any object, and you can make small objects like feathers and things float. That doesn't mean that's the cause of the downward acceleration when it's not there. Oh yes, it is.
Wait, what do you mean when it's not there? You keep saying when it's not there.
In a vacuum or in some lesser electrostatic environment.
It isn't a vacuum. I just now explained that.
Lesser doesn't mean not there.
There's an electric constant in a vacuum, Zanick.
In a vacuum.
Yes.
I'm agreeing. I'm repeating what you said. And with the Van de Graaff generator, you are now creating a field, an electromagnetic field that's exposed to a small object in the vacuum.
Show me your measurement of space-time in a vacuum, please.
Dude, you don't even know between impedance and resistance, so just go away. Come on.
Okay, so here's
you don't know the difference, bro.
I do know the difference.
Resistance is just with resistors. Impedance refers to everything, Zanick. You're talking about just little resistors, bro. You don't know what you're talking about, bro.
It only applies in an AC circuit. Impedance only applies to an AC circuit. And it's everything.
Yeah, every component, Zanick, not just a resistor. When you say resistance with impedance, you're talking about just a little resistor and nothing else.
We're talking about in space. There's no AC current flowing into space. We're talking about DC current.
Nobody said, bro.
All right, look,
bro, we're not talking about capacitance.
How do you know anything that's going on in space, dude?
We're talking about resistance of the medium. You talked about this earlier.
Here's Missouri State. Missouri Science and Technology University. This is Montana University. This is NIST.gov. all explaining the vacuum electric permittivity. So in the electric constant in the vacuum. So I'm going to drop the 3 sources for you because apparently you couldn't Google the words I've said 30 times. And please stop saying that there's nothing
I'm
there.
not Googling, all right? I'm not here to
I said apparently you couldn't Google it before contending it. So anyway, here's an article. There's a source, dielectric electric constant, permittivity in a vacuum. This is well known that there is free space impedance. Okay, here's a PDF from Montana University. And here is the government. So you should definitely believe them, right? That's your priesthood, bro. That's a joke, don't get triggered. Government. Okay, so vacuum electric permittivity. That's an electric constant, even in a vacuum chamber. There's also magnetic permeability, a magnetic constant in a vacuum. So please stop saying when it's not there, because it's always there, okay?
We know it's there. You're saying you're adding to it. And where does it say magnetic impedance? Whatever you said. There's no impedance in this article. You just made that up.
I said this is this is not about the impedance. This is about the
electric permeability, dude.
No, he said the electromagnetic impedance.
He said permeability.
He said impedance. That's why I looked for impedance in his article.
No, I was also explaining. I was explaining it. So what I said was, these are the articles showing you that there is an electric constant and electric permittivity in a vacuum. Because you keep denying it. You keep saying when it's not there.
You also said impedance. Did you not?
Then I went on to explain. Yes, it's well known that there is impedance in free space. In a vacuum chamber.
Again, only applies to the AC circuits. And impedance includes inductance, includes capacitance.
Bro, would you just listen and learn something, man?
Dude, I'm not going to learn anything from someone who's learning on Google. And I've already been through this my whole life. I haven't touched most of this stuff in.
Would you at least please quit switching back and forth to he's adding something to the medium,
yes,
or
it's
not there to begin with? Quit interrupting, bro. Or it's not there to begin with. So quit acting like it's not there to begin with.
It's not there to begin with. The feather is not electrostatic.
Unbelievable.
It's not electrostatic until you induce a field near it or around it in the vacuum.
So what happened 2 seconds ago where you said it's already there?
It's not already there.
I find it to be pretty believable, honestly.
Unreal.
Yeah.
So it's not already there. It is already there. It's not already there. It is already there. You literally go back and forth.
Not already there.
We heard you.
There.
Zanick, just click on the article. Click on the government article right there and stop talking. There's the government telling you, literally, that there is impedance in a vacuum. And guess what the number is? Okay.
Let me guess. 377. 367 or 376.834 something.
Yeah.
That's because I was listening, Zanick. If you'd have listened, you would have denied it. You would have learned it.
Wait, you said there's impedance in the vacuum.
You're laughing when you've just been destroyed.
No, it's not been destroyed. You're not making any sense. The things you're saying. You
Just
keep on
Zach, if I have a spark gap in a vacuum, what do you think the resistance is? What's the resistance there? If I have 50 amp and under 10 volts in a vacuum, you know what? We can figure that out, bro, because we know the freaking resistance. Okay, it's Ohm's law, bro. So what's the impedance in the vacuum? The spark gap of the free space.
You're using the word incorrectly, Brian. It's not used for DC circuits. It's used for AC circuits.
Talking to you is impossible.
Do you actually want to read the paper? Here you go.
I didn't say AC or DC.
On the ratio between the von Klitzing constant and impedance of the vacuum, or that math is the golden ratio. Okay, there's a paper you can read. Oh, just stop making it weird, man. Makes it weird. It's like, yo, it's not even a big deal. This doesn't even mean I'm right. I mean, I am right, but
you're not right. God, you're not right at all.
Zanick, I am.
You've added something to an environment which caused something to flow. It didn't counteract. It added to the environment. You
Counteract
added the
what?
environment. Stop it. You have something that has some weight, and now it's floating in a vacuum because it has charge, and it's reacting into that environment based on that charge, based on the static electricity. It's nothing that unusual. No one's not invented anything. You're not disproving or proving anything other than you don't understand how gravity induces a force and mass.
See, the source of Cognos here is because it's such an obvious phenomena
And
that
there's
everyone knows about. You're
millions of
like,
physicists that would
stop,
agree with me and
dude,
not
stop
you.
interrupting me. It's such an obvious like phenomena that everyone knows about. In your mind, you're like, there's no way that this could actually be the explanation because we all know it exists and everyone believes in gravity. Every physicist believes in gravity. So therefore, there's no way that this could possibly be it. And so you
It's not a
have
matter.
you have that assurance. You're very confident in that, right? Like there's no
No, it's
way.
not an issue. I've already experienced this. I've used this in many years of engineering as well. The
You never
gravity
use space-time, Zanick.
No, we don't need to. Did you not hear what I said earlier? We don't need to know what the cause is. If I work in the field of Newtonian mechanics, it all works perfectly well. Perfectly well. I'm not
Yes,
doing things at the
so
galactic level. Shut up. And I'm not doing things at the quantum level. Everything in the world we can see and touch works perfectly. There's no electrostatics that account for any of these things that I've worked with over my careers.
I can use a kinematic equation as well. Like I could do everything that you do with Newtonian mechanics on the Earth. I could use a kinematic equation to do all of it. I
But
don't need
they are kinematic equations. That's what Newtonian mechanics
like
is.
a base
You're
kinematic
being silly
equation with
now.
initial velocity, height, and time. I can
Yeah.
get downward
How do you do
acceleration.
that? Show me this acceleration by static electricity values, and
Well,
then show me.
again,
Then
so
stop. Hey, I'm talking. You know I'm talking. You heard me. So then you get that experiment together where you actually have an object where you induce some type of field around that object and see if you can simulate 9.8 meters per second or something close to that, and have it repeatable with different types of objects of different mass.
so what you don't seem to understand is
Oh yeah,
that
I don't understand. It's me.
I know.
A lot of projections.
So there's a downward electric flow on the Earth, yes or no?
Not always.
When is there not one?
When there's not current flowing.
When is that?
Inside
Whenever
any
it serves not
Faraday
to be.
cage.
Inside any Faraday cage. So is there always a downward electric flow on the Earth in nature?
There's flows, electric flows all over the earth in all directions.
So the Faraday cage is grounded. So where's the electric flow going to?
Through the cage.
Through the cage
skin of the
where?
cage. What?
The skin of the cage to the ground.
Oh, okay, so it's going down. So but there's nothing inside
Grounded
that.
up.
There's
It doesn't have to be down. I can have the ground upward,
Oh.
knucklehead. Come on.
Hey, is there an electric constant inside the Faraday cage?
What electric constant are you talking about?
There is always an electric constant.
In the Faraday cage, there's
Even in a Faraday cage.
What is an electric constant?
I don't know. He's making things up again.
Electric permittivity.
Which is it?
That's what the electric constant is.
Electric constant, I remember being K. In fact, it's in your article too, K. Oh, that's a dielectric constant.
Yeah, okay.
Which is, so you tell
how
me what
about
it
you
is.
read the articles then, dude?
It's not that long. I'll read it right now.
Oh my God.
You're talking about the capacitance of a circuit.
He's literally asking questions on things he don't know, like he's quizzing you or
Oh,
something. That's
you're
ego.
Brian,
You're
the smart-
arrogant,
you're the
bro.
smartest guy in the room,
Literally
right there.
arrogant, bro.
Yeah, right. Now, I would never use the fact that we have a billion scientists on the earth that think like that. How I think. That's
You
not
always
the
go
point
back
here.
to the
I
billion
wouldn't use that as
scientists,
an
bro.
argument. I wouldn't use that as an argument. What I use an argument is that I've
You've
worked
done
in
that
the
5
field,
times
and
tonight,
none of these. Why do you feel compelled to talk when I'm talking, Brian?
Because every time you get trapped, you say the billion
So
scientists.
that's your reason. That's the reason you're interrupting me. Stop using that as a reason and stop doing it. Okay, just blabbing things out, and you're yelling too. So just stop.
Bro, you're
yelling.
not being honest, bro. Okay, you've
I'm
been saying
being
that
honest.
all night. Every time you get stuck, you say every scientist in the
That doesn't
world.
give you.
This and that.
No, I say I'm not going to use that. Even that could be an easy fallback. The appeal to
You've been using it all night, bro.
No,
Wait, can I just please say this, man? Because we move on. You guys are boring me, bro. Like,
hold on,
dude,
I'm
this is the
responding to
thing. The
him.
Faraday cage is used to block like transfer from external charge, right? Like it's so that you can't have transference from outside to inside the cage, right? That's the idea. It doesn't remove what's inside the cage, and there's always an electric constant inside the cage, and it doesn't stop
Why?
magnetic fields. It
Says
doesn't
you.
block magnetic fields.
Says you.
So you're saying
you have a
Faraday
Faraday
cages
cage,
eliminate
how is
magnetic
there an
fields?
electric field? How is there an electric field that was there before the Faraday cage was grounded, and now there is grounded? How is that field still in the cage?
Faraday cage cannot block a stable magnetic field.
It's not designed to.
Okay, so then why are you arguing it?
Because a magnetic field is not.
What?
Would things inside the cage weigh different?
Would they weigh different?
Mm-hmm.
Why would they weigh different?
I don't know. You're blocking this downward flow of electricity.
Yeah,
That
you're
you're
not
saying
completely eliminating the electric nature, though, and all it has to do is be there at all. It sets the up and down. And then the intrinsic electric nature of the object is what allows it to have a compactness of matter, also known as density. So that's what's going to give you the weight based on the relationship of that density with the relationship with the density of the object.
Oh, okay. And then when I drop a box with many different variations of density of mass, they all float, and there's no preference which direction or how fast they fall. They all fall the same.
You think the weight is that the center of the object is the center of a gravity well, and that it creates this well in space-time, and that it guides it down, giving it weight.
So
you're sitting here
again?
laughing about something we can actually prove.
So we're going back to that again. We're going back to the cause of the cause.
Yeah, no. I'm exposing the hypocrisy of you ridiculing a position that can be verified.
You've said in not so many words that density is the cause of these things going down, having acceleration. Because you put in a Faraday cage, and then the density will determine how fast and how much force you will have.
He said density is real and we can measure it, bro. Unlike space.
But if I put all multiple different objects, all the same size, in grossly different densities, like a ping pong ball made of lead, a ping pong ball with air in it, a ping pong ball made of gold, whatever the substances are made of, liquid, waters, whatever you got, and I drop this box in the Faraday cage, it's going to still, every object in there is going to be floating, and there'll be no preference of acceleration or force to any one of them.
What does that have to do with space-time not being measurable, testable,
who cares?
or verifiable?
Wait, can we get you guys to? This is the only way to have a conversation with you guys is for you guys to point blank concede one thing at a time. Do you concede the Faraday cage does not completely eliminate the electric nature of the medium and the objects?
I don't even know how to answer that one.
You do not answer it. You don't like the implications of the answer.
You're trying to find gotchas to make your.
It's not a gotcha. This is how you debate.
It's a total weak sauce case.
Okay, so the answer is no. The answer is no. Okay, they are not perfect, and they do not wholly block all of it. They do not prevent 100% of electric transfer. They do not. Now inside of it, there's still an intrinsic electrostatic nature of the object and that medium, which means there's still a transfer from that medium to the object. And even if you put a Faraday cage in a vacuum chamber inside a Faraday cage, you still would have this problem, because even in the background of the vacuum, there's an electric constant, which means there is always a transfer of electrostatics from the medium to the object. Always. There's always a relationship between the medium and the object. A Faraday cage does not eliminate this.
But couldn't we effectively eliminate all of its bias by electrically introducing an opposite polarity of an electric field with a voltage source?
If you introduced a strong enough one, then you would.
Well, inside a Faraday cage, it's going to be an extremely weak field, if any, because the conductivity of the Faraday cage is 1 billion times greater than that of the air, right? Will you concede that?
Sure.
Okay, so it's so close to zero. All we would need was 100 volts for over a 1 meter space to equal the 100 volts per meter that is in Earth's atmosphere, right? Would you concede that?
Well, it's gonna immediately dissipate though, right? How are you
Not
gonna? How
if
is it? Huh?
Well, if we have a 100-volt battery in there and it's hooked up to a grid at the top or the bottom of the Faraday cage, creating this potential, this gradient between the top and the bottom of the cage, and it's less than a meter, and it's more than 100 volts, then we have an excess of 100 volts per meter, right?
You
You'd have
think
to
it's gonna
hover something to
maintain?
test that fairly. You'd have to hover something in the Faraday cage.
You think it's gonna maintain a constant value of equipotential from top to bottom inside a Faraday cage?
If you have a panel, like say at the top of the cage, that's insulated from the cage, but inside the cage, and you've got 100 volts on that panel, then it's going to provide 100 volts per meter gradient if the cage is 1 meter high, for example.
Okay, but that's not gonna make the object float. First of all, we have to talk about what object it is, right? Like if it's a heavy object at all, it's definitely not gonna do it. But this is the same reason that like during a lightning strike, whenever there's a temporal flip of the polarity of the field locally, things don't just begin to float up. And some people pretend that's a refutation of my position, but it's not, because the object itself is intrinsically electrostatic, and that density relative to the density of the object is still going to result in it's seeking equilibrium down. So the question is, what is happening with the density relationship? Well, it's all intrinsically electrostatic. The entire field, the entire Earth has a field, an overall field of the entire Earth, right? You're not going to change that. You can't change the whole entire field of the Earth.
But can't you block it with a Faraday cage?
You can't. We just discussed that you can never entirely block electrostatics.
But how close can we get to blocking it? Let's say it's 100 volts per meter outside the cage. How many microvolts per meter can we get it down to inside the cage?
It doesn't matter if it's like the smallest amount conceivable, because it's still stronger than gravity claims to be. So.
Okay, and what if we then took a voltage generator and a panel, an insulated panel inside the top of the cage, and reversed the polarity of that electrostatic field inside the cage to oppose the Earth's in the opposite
You're just
direction?
adding to the incoherency. All you're doing is adding to the incoherency, bro. You're not technically truly reversing the field. You're just adding to the incoherency of it.
No, again, if the object was light enough and you introduced enough energy to flip the polarity, if it was enough, then the object would float, just like it does in a Van de Graaff generator.
But I still don't understand.
Jesse, don't you realize that even if you have 100 billion quadrillionths of 1% of freaking of charge still in there, that's all it takes, man. That's
Exactly.
to be stronger than gravity. That's what y'all are failing to recognize.